Assalamualaikum and hi, my name is Ahmad Iqmah Hakim bin Omar. Today, I would like to present my bachelor degree project 2. My title is Development of a Robotic Hand for Electrical Installation Purpose. My supervisor is Encik Arman Hadi bin Azhar. Here is the poster of development of a robotic hand for electrical installation purpose. In this poster, there are introduction, problem statement, objective project, scope of the project, literature review, research methodology, result and analysis, conclusion and recommendation, and lastly, reference. Introduction of the project. Present day, the construction sector has been critiqued for being reluctant to implement new technology, and labor productivity has been remained stagnant. New technology is required to replace human work to ensure the electrical construction grow faster, accuracy, and safely. Robot technology used in automotive factory, military, office, and hospital sector, especially to facilitate human traction at high risk. Hence, a robotic hand is invented to solve this problem. Problem statement. First problem is highest in workplace. Second is higher unwanted accident in manual electrical handling. Lastly, to avoid direct touch during hazardous electrical handling. Objective of the project. Firstly, to develop a prototype robotic hand that hand user can control. To create a robotic hand finger, utilize flat sensor and wireless communication. And lastly of the objective is to develop and evaluate the finger control system. For scope of the project, there are 5 flexible sensors in this project that symbolize the 5 finger of robotic hand from 0 degree until 180 degree. 2 ESP microcontroller were used as a primary controller device. For process aspect of the project, and lastly is there are 5 servo motor in output portion. This servo motor can control robotic finger by tying a thread to the servo motor shaft and connect it to the finger of the robotic hand. This is literature mapping that I have gone through about this topic. Variety of robotic hand has been developed by the research such as Building, Zizu, Brasilia SRL, D. Camelin. For control design, mainly the research focused on the CPU and EMG, as you can see more here, while the mechanical design is mainly focused on grip and grasp, most also here. Hence, with this research gap, I developed a robotic hand using flat sensor that can grip and grasp. Here is the research methodology. As you can see from the right is control design, and aside from that is mechanical design. For control design, there are 5 flat sensors as main sensor or input, source power to power up the flat sensor, glove to tie up the flat sensor using thread. Connection between DESP32 is called ESP now via using Wi-Fi, and for mechanical design is 5 servo motor as output, source power to power up the ESP and servo motor, 3D printer for mechanical design. Then lastly the robotic finger tie up from the servo motor to the design using thread. Below is the design that I create from this methodology. Project demonstration. First, my project divided by 2 parts. First part is control design, and second part is mechanical design. To power up the control design, we need a power bank, and to power up the mechanical design, we also need power bank and power supply to power up the servo motor. Okay, now let me see the movement of every finger of robotic hand. Okay, firstly we need to power up the control design. Here is control design with the power band. So at mechanical design, I also power up with the power bank. Okay, now let me power up this finger. Okay, now let me see. First finger, second finger, third finger, okay, fourth finger, and last finger. Okay, now let me see this robotic hand finger grasp this screwdriver. Okay, as you can see now, this robotic hand can grab this screwdriver. Okay, now we pass this finger. Okay, now let's see, we see this first again. Okay, this robotic hand grab this screwdriver. For the result and analysis, the graph for the rotation of the flat sensor versus rotation of servo motor and robotic hand finger were plotted. The rotation of flat sensor as the input and the rotation of servo motor and robotic hand finger as the output. From the graph, we can see that the rotation of the flat sensor is directly proportional to the rotation of servo motor and robotic hand finger. When the flat sensor bend 180 degree, the servo motor and robotic hand move 180 degree and 90 degree respectively. This shows that the movement of the robotic hand and servo motor has been correctly with the flat sensor. The table 1 shows the range of the flat sensor value based on the rotation of servo flat sensor. This shows the minimum and maximum of the flat sensor value can be obtained in specific rotation of the flat sensor. For example, at 0 degree, thumb finger show flat sensor value in range 2090 until 30,000. Lastly, I also testing for the wireless communication of between control design and mechanical design. I obtained that the robotic hand can be controlled by controller up by 25 meter. As a conclusion of this project, the robotic hand successfully moves simultaneously with the controller. The robotic hand movement correctly to the flat sensor up to 25 meter of wireless communication. And lastly, the rotation of flat sensor directly proportional to the movement of the robotic hand finger and the rotation of servo motor. For recommendation, I suggest we can add IoT system for faster to collect and examine the data using a device such as a smartphone. Servo motor may be switched with the stepper motor or high torque motor that can easily work or hold anything without causing to fall. And lastly, robotic hand can be rotate 380 degree. Here are some of the reference that I use for this project.